Hi Parilla lovers, I'm PJ Johnson and I have promised a video to everyone, the newcomers and the people that are not familiar with the internals of a Parilla high-cam engine. I promised this video for quite a long time and it's high time that I got around to doing it. So this is more or less an introduction. It's not going to be a particularly technical video. A single video can't make a mechanic out of anyone, but it will show those people that are a little bit timid about trying to find out what's inside of one of these engines. It'll give them a leg up on not being afraid, perhaps, to go ahead and try one. Many of us agree that it's one of the prettiest engines that has ever been manufactured, and I got to tell you the truth, I do agree. And so without any fanfare, I think we ought to just go ahead and tear down one of these engines, see what's inside, and learn a few tricks about how they go together and how they can be assembled somewhat easily. So there's really only one more thing to do, and that's to go ahead and get started. Okay, it is May 12th, 2005, several months before Parilla Days 2005, and as promised, I'm going to disassemble this engine. It has been rebuilt, and it hasn't had any oil put in it, so it's going to be a little bit neater and perhaps a little bit cleaner to take this apart and show what there is about heard a funny sound. Okay, show what there is about Parillas that's unique, and perhaps a little bit about how to rebuild them. As I mentioned, this is one of 10 that I built back in '96 before the first Parilla Days event, and it hasn't had any oil or gas or anything in it. And I will proceed to take it apart and not only show what's in it, but talk a little bit about what a guy would find should he take one of these things apart. Okay, I'm going to start with the dry side of this engine, not because it's the easiest, but because in many ways it's the most complicated of the two covers. And I have just recently taken the Allen heads out and I put them in order so that I can always be sure to have them go back in the same hole. And that's really a good idea for any novice guy taking one of these things apart. I actually take a piece of cardboard and I kind of sketch out the bolt pattern in the cardboard, punch a hole in the cardboard, and stuff the bolt in the hole that it corresponds to in these covers. So I've taken the Allen heads off, and it should be relatively easy now to go ahead, I'll see how this works, and take off the cover. Well, maybe it won't be so easy after all. Hang on for just a minute, I just got to break it loose. Now I did try a remote microphone to try to eliminate the machine noise coming from the video recorder itself, but it turns out that with all the lights that I have in here, I get lots of extraneous noise. So I think the main thing is to just put up with the noise from the video machine itself. At least it will be consistent. And from there, I'm just going to go ahead and just gently coax this thing apart. And you notice that the shift boss seems to want to stay with the inner part of the engine, and I don't have a problem with that. I'll just let that happen and tickle this thing apart. I'm usually blocking the video camera for this, but okay, here she comes. Okay, now you'll notice that I've got a shim in here. This particular engine seems to want a shim between this and the cases, so I do that. And I would say that there's no real need to have any gasket here because this whole area is dry. And these oil seals, if I'm not mistaken, the oil seals in all three of these places are all the same size. So you pop those in, and this area then will stay consequently dry. Now, this is the shift mechanism. I've painted the post on the mechanism itself yellow so that you can distinguish it. And I'll have to get a look at this. You can see that this spring here has to be spread so that the two tangs will be on either side of the yellow post. And it can only go one way. If it turns 180 degrees, it doesn't fit very well. So you'll know right away that of the one correct place that it does fit. Okay, now the back of it is spring-loaded. This one has been cleaned, but as you can see, it's spring-loaded by a sort of a band spring. And all of this mechanism just should be cleaned and put back together, and it should work just fine. Now, this has to be spread in, oh, I just lost the shim. This has to be spread in this way to have these two tangs or teeth fit on this area here of the shift lever. And probably the way that this fits the best is about like so. Let me zoom up to show that a little bit better. And it kind of lines up with the piece, and by the way, this is the clutch rod here. Kind of lines up with this. And the thing about this is that when the cover, this cover, actually goes on, this piece here goes in here. I hope that can be seen. And you've kind of got to line it up and make sure that it wants to go in between the two springs. And it's in position for one of them. So when I pull down after it's got a hold of the one, then the rest of the cover will fit rather nicely. Okay? But you've got to remember that if there is a spacer that is needed, you've got to be sure that the spacer is in place before the cover is put on. Okay, we're going to look now at the ratchet and spring for the Kickstarter. Okay, the ratchet and circular spring are correctly set in place, and generally speaking, let's see if this will go down. The Kickstarter starts in this kind of a neighborhood. I'll zoom back so you can see the whole thing. Okay, and as you can see, it wants to spring backwards and will only tolerate a 1/2 or 180 degrees of rotation. So now what I'm going to do is I'm going to flip this over and show you the inside and how the spring actually is situated on the inside of the Kickstarter, and how, if you have one of these, how to set it up. Okay, all I've done is take off the kick lever itself, and now I will turn it over so you can get an idea how this should look. And I'm going to zoom in a little bit closer here so that we can see what it is that we're actually dealing with. Now, this is under a tremendous amount of tension, and as a result, if I remove this gear, the fan gear, for want of a better term for that, is just going to turn loose of itself, like that. So, what we need to do is find out where the rest position is, whoops. That's pretty much the rest position with the actual Kickstarter gear taken out. And as you'll see, if we try to just simply lift this gear, it'll come out of the spring, which has got a hook here. I think you can see the hook right here on the spring. Boy, this thing doesn't want to aim. Okay, I think you can see the hook to the spring here now. It is right here. This hook will fit in one of these 4 grooves. You got to select which one. This one I have marked with some red paint, although it doesn't look red right now. But this is the one I chose to put it in, and it had the spring wound as tight as I could get it to wind. Okay, now I think it's marked red, and that's the slot I am going to try to hook that hook into. And I will literally hook it in like so. Now you got to understand, I'm having to struggle by looking through the viewfinder, make sure that you can see this. Okay, and it hooks like so. Now this is further complicated by another thing, which is the other end of the spring. This end here is attached to this post right here. Now it'll be attached to that and not in tension, not wound up. But while all that's going on, this spring cover piece needs to be over the top of things. So it's not going to be all that easy to get this in position, but I will get it in position and then show you how I personally wind this up and then drop the other gear in place. Okay, I've kind of put the spring into its marked position, and as you can see from the other side, the piece of shielding tin for the spring is in place in between the spring and the gear. And now the only thing that I will have left to do is turn the gear over, drop it in its appropriate spindle, and get this piece over that pin. And I'll do that, but there's no sense in you watching me struggle to get that done. Up, and as luck would have it, I installed the spring backwards so that it would wind in the wrong direction. So this is the correct way to wind the spring, and you can see the hook is in the painted marked area. And I'll try this time to see if I can't succeed. In getting the little part here attached to its little pin too. Yeah, that looks like that's going to be closer to doing the job. Alright. Okay, and there we go. Alright, now the last thing is going to be winding this spring, and that's not a particularly pleasant or easy thing to do, but I will wind it, and as soon as I get it wound, I'll take this gear and drop it in so that it will keep it from unwinding. Okay, and this is the approximate position that the gear with the spring, before it is wound up, should be in before being wound. So I'm going to try just once to see if I can't wind this spring the way that I normally do it while the tape is running. And if we get lucky, I don't know if this will show. I'm going to zoom out and then have my hands and everything are going to be in the way. But this, I'm sure, is not the absolute accepted way to do this. But now you get the idea, and I have to do it free of the camera and free of all elbow encumbrances so I can do it smoothly. I've tried to do this a number of ways without special tools, and it could be that this is going to be the last of it. I've gotten one rotation out of it, and I put this gear in to hold it from that one rotation. Now I'm going to try to get the second rotation. Nope, doesn't want to go. Okay, we'll try it once again with this is, of course, without special tools. That's one rotation. Hope you can all see that, and I dropped that gear in. And now I'm going to try to get the second rotation, and I may be successful, and then again I may not. We'll just have to see. Yes. I hope that was able to be seen. This is all a special tool thing, and given that I don't have the special tools, we have to go with what we've got. Okay, and I'll have to rotate just a little bit more so that this gear will drop all the way in. And I'll try to do that now. Now, everything wants to get in the way, but we shall see. Almost. There we go. Hope that's able to be seen. Okay, now a couple of things need to be noted. The tachometer drive, which is here, needs to drop into a special bolt that screws onto the end of the crankshaft on the right side of the engine. And you need to keep in mind that that screw, or that special bolt, has got a left-handed thread. And you don't want to tighten it too tight, and you definitely don't want to snap it off in there. The other thing is that this is a little rubber piece, and there is a sort of a fulcrum pin that goes in through to hold this clutch mechanism. And along with that, Hope you can all see this. This is not so easy looking through a viewfinder. This is the clutch actuation piece that pushes on the clutch rod, which goes all the way through the engine and pushes the plate, the pressure plate, out from the clutch so that the clutch will release. Okay, something else should be noted, and that is, at all times and if at all possible, the engine should be in neutral. And the best way for you to know that it's in neutral, after this gear is put in and this gear is positioned in its correct spot, is that there is a mark right there and another mark right there. And that is the position that they should be in when you go about assembling this right-hand side of the motor. I hope that's clear enough. Okay, now, so to reiterate, I'm going to go ahead and put this piece back in place. It's got to have this little bit spread. It's got to have that shim in place that I keep dropping. And I will do that now. You little devil. And you can see that everything is now in place so that the cover can go on relatively peacefully. And we'll do that now. You'll see this post here goes in the center of here, but it won't be able to go all the way in. It will just get one side hooked. And that'll be roughly about there. Then we pull it into alignment, give it a bit of a smack. Doesn't want to behave this time. Always a reason for this stuff. So we'll have to see what gives. Yeah. Okay. There we go. There we go. And by the way, these are dead blow hammers. I don't know if you can hear the shot that's on the inside of them, but they give a very gentle hit, but a very sure-footed hit. And they don't mark anything up, and I've got a number of them. I've got a small one, medium size, and a big one. And they really do help in taking apart and putting these things back together again. So now the only thing that would remain on this, and probably I wouldn't have this particular tachometer drive in place when I put the cover on, because I would want to know that the little blade in the tachometer drive was aligned with the bolt in the crank, which by the way is not there just now, but I'll show you what it looks like in just a minute. Now most of the other... Okay, I've removed the cover, not the cover, but the tachometer drive, and I just wanted to show you where that specific bolt threads in to the end of this crankshaft. And this is the one that I mentioned is a left-hand thread, and you really want to be careful with it. And this is the bolt that threads onto the end of the crankshaft. You probably can't see that from here, but no, would it focus? No, there we go. It is a left-handed thread. And I'll go ahead and thread that in position now. Just dry threaded. Okay, the bolt is threaded in position now, somewhat cinched, but as a result of having to cinch it, I had to move the crank a little bit, and so I'm going to go ahead with a Chevy push rod up top here to re-establish top dead center. As you can see, the rod moves up and down because the piston, I want to get it as close to top dead center as I can get it. That's pretty close. So then, when the time comes to put the tachometer drive in place, I just make sure that this little blade here is going to line up with the slot in here while I put the Allen head bolts in place. There's not much more to that than that. Now, the only reason that I don't have an ignition system in here right now is because this engine is going to run a PVL ignition system, which I run on all of my race bikes, and this one is going to end up being another race engine. So I will deal with that later after I have pulled down the entire engine for a video, and I'll go ahead and install that. I'm not entirely sure that that's useful for a lot of the folks that want to know how to rebuild engines, because PVL ignition, like the stuff that Gary and Bob Moon use, are rather specific. Actually, if the truth be known, their system provides for a lighting system as well. Mine does not. I don't run lights on race bikes, but they both of them ran their system successfully while running lights in the Moto Giro d'Italia. So theirs is a pretty good system as well. Now I'm going to go ahead and put the Allen heads back in place lightly, because we're going to deal with the left side of the engine now. And I don't know if you can see this, but this is an Allen head 5mm driver. And these are pretty nice. They've got the little ball end on them. I'll see if you can see that. Let's see. Yeah. And I'll use this to more or less snug up all of the 4 Allen heads, the 5 Allen heads that are on this right-hand cover. And then I'll go ahead and I'll put the tachometer drive back in place with this as well. And then from here, we'll move on to the other side of the engine cover. Okay, so this right side of the engine is loosely assembled, and I will now leave it to move over to the other side. And this, of course, is the clutch side. This is the wet side, and this is the side that it's pretty critical to get sealed well, because boy, will this sucker leak if it isn't sealed well. Okay, this particular side it's kind of like a Chinese puzzle, and that's unique to Parilla engines. The push rods, which you can see here, keep the head from being removed cleanly, and they keep this cover from being able to be removed cleanly, independent of one another. There's got to be one thing in particular that has to be done in order to remove the cover and the head, and that's this. These rocker arm covers have got to be removed, and usually this oil line here would be removed as well. And then the rocker spindles, which you can see here, have got to be removed. The rockers then have to be removed, and the push rods have got to be extracted. That way the head can come off if you decide you want to take the head off, and the cover can come off if you want to decide to take the cover off alone. And in this case, we're just going to take the cover off, so we'll have to remove all of this other material. And what you've got to be kind of careful of is that behind this nut right here is the injector nozzle from the oil pump, which is down in this area here, will actually fall out if you're not careful. So it's often good to remove the nozzle, its holder, and the spring by taking this nut off and then reaching in with a pair of long nose pliers and taking out all of the very looseable little pieces that will naturally fall out as soon as the cover comes off. So I'm going to go ahead and do that now. Okay, I've cracked that nut loose, and I will now remove the nut by hand and then try to be sure to catch the material that is behind it. There's also a fiber washer underneath this nut to give it a good oil seal. Let's see what we can find in here. I've taken that particular set of nozzles, springs, and containers out beforehand, so I'll have to lay that stuff out and show it to you. Okay, this is the injector system, and it goes in this order. This is the nozzle, this is the spring container, and of course this is the spring, and the spring is of a certain thinness or thickness, whatever, that will deliver a certain amount of correct tension, pushing the nozzle against the end of the crankshaft. And actually the oil will go through the injector nozzle into the crank cheek, and from the crank cheek it will turn at a right angle, go all the way up to the crank pin, turn another right angle, and oil will be delivered to the crank pin itself. And it will be delivered to the crank pin where the main bearing is, and where the big end of the rod is. The other thing to mention is that there are varying sizes of holes for these nozzles. I've seen a number of different sizes, anywhere from 120 thousandths on up to around 200 thousandths, and on down to as much as 110 thousandths. Not entirely sure what's correct, so what we do is we try them out, and then if there's too much flow to the crank, we'll solder this thing up and drill a smaller hole in it. Okay, I measured this, and even though the hole looks huge, it is 116 thousandths, or a number 32 number drill. And that jives with a lot of the other ones that I have here. That's about stock for its size. Okay, and here they are laid out again. This goes in first, this will go in second, and the spring, which I dropped, will go in third. And I'll put them in now so that you can see how that actually functions. I'll put them in like so, and then after a case of the dropsy, I would put in the main bolt, put it down, and cinch it down. So now I'll go ahead and back it out so that I don't lose that. And I'm actually going to take those pieces and put them in a baggie, a little tiny Ziploc, and put them in. Okay, I've raised the camera up a little bit, run it on the tripod a little higher, and I'm going to remove a few of the essential pieces. I'm not going to take the other ends of the oil lines off because this stuff is kind of hard to get a seal. And once you do get a seal, I try not to disturb it any more than I have to. And by the way, these are my own handmade banjo bolts. And they allow the oil lines to come off in a V rather than either come straight out or one line straight over the top. I just like the looks of it better, and I like the way that it feeds better. Okay, now I'm going to get my Allen wrenches and turn loose of the rocker cover. Okay, the 4 Allen head bolts have been taken off the rocker covers. So the only thing that's kind of holding everything in place is this central banjo bolt. And I will now remove that and take the entire business in toto out. So now I'll have to get the camera by hand to show what it looks like inside of the rocker covers. Okay, I'll use the camera handheld with a flashlight, and I wanted to let you get a look. This is the intake rocker, and I hope this will show how the rocker is shimmed up in such a way that the rocker itself bears down on the center of the valve stem, and there is one big shim on this side to control the up and down or side play movement of the rocker arm in such a way that it bears on the center of the valve stem. And I will eventually have to remove this rocker spindle and then go ahead and remove the rocker arms themselves. Now you notice that I don't use those little springs that are supplied with Parilla. I don't think they really do much. It's just my personal opinion, and that is my personal choice. And now we'll have a look at the exhaust side. And as you can see, there's a fairly thick shim on the top of this rocker, and a rather thin one on the bottom. All of this is just aimed, once again, at making sure that the rocker sits in the center of the valve stem. And as you'll be able to hear, there is some lateral motion left possible so that this rocker arm doesn't bind. And by the way, with my engines, these look particularly clean because I have polished the rockers, I polish the rods, I polish a lot of other things, not necessarily necessary to building a stock motor, but it makes them a little bit stronger if you were to do that for these racing engines, which have rather heavy valve springs and put a lot of strain on the rocker arms. So now I'm going to go ahead and pull the spindles on both of these rockers, and pull the rockers and then pull the push rods. Okay, and something else I'd like to bring to notice, I put the Allen heads back in their places where they hold down the rocker covers, and I put them in the same holes. This just eliminates a lot of problems, because on a lot of these Parilla situations everything is so different. You need a short one here and a long one here and so forth and so on. Now there's something else I'd like to point out too, and that is this. This particular rocker spindle cannot be removed until this bolt is removed, and you'll notice that this bolt is broken in half, and it's not so easy to do, but I've arranged this, and I've actually customed up these bolts so that I can pull the top half of this bolt so that I can remove the rocker cover without untorquing the head. It looks like with the top half of this bolt removed. Now, of course, the reason that these are here is because these are the bolts that are attached to the head steady, which goes to the frame, and that ends up being pretty important. So if you can build up long nuts that are of equal height on the front of this engine, then your head steady bolts, or the head steady mechanism and the bolts, will drop down flat just fine. Okay, so I'm going to lay the parts out in the same way that the engine is facing, like. Okay, so now I'll remove the rocker spindles. These happen to be 12 millimeter, but I have seen them with 14mm heads. Doesn't seem to be a way for me to not be in the way of the camera. But I'm taking the rocker spindles and I'm placing them in the appropriate place, taking the rockers out, making note of where the shims are, and then I'm putting the rockers back through, rocker spindles back through the rockers, noting where the shims are. One on top and a thin one on bottom as shown, and putting the rocker spindle back through the rocker, and then as you can see, just lay this stuff out in the order that it was disassembled. And then I will just use a little light magnet to retrieve the push rods, and you will see them come out of their little holes. And I will put them with their rocker arms so that I don't end up having to remeasure everything. And that's generally the way to approach this, to be real fastidious and do it that way. Now the cover is free to come off, and by the looks of things I will attack the removal of the cover in the morning. Well, good morning. Guess we're going to start now on the timing side cover. With my trusty nut driver, I'll take all the Allen heads now. They are loose. I'll go ahead and take them all the way off. I'm going to tape the rotary table so that it doesn't move when I try to work on it. Okay, all of the bolts have been removed now, and I will show the way that I take this thing apart. It's fairly gentle, and I use the leverages of places where things naturally have a tendency to give you help. Now it's the alignment pins that are the thing that make it somewhat difficult to take these covers off. And there's an alignment pin. There's another one over here. I expect there's one on the cover itself. No, there's just the two. Okay, so now, as you can see, a couple of things, hang on. Okay, there are a number of things that can be said about this timing side. If the engine runs in a top forward position, like so, you can see that as it turns forward, the camshaft rotates backward. And you will also be able to notice that the cam lobe is as far away from activating the push rods, both of the push rods, as possible, which means that at top dead center this is on the compression stroke. There's a long article or a long bit of dialogue about whether chains or the gear drive up to the cam is better, and I only have one gear drive motor, and it has yet to be completed. So I don't really have a lot of experience with respect to the gear drive motors, but I've heard a number of the racing competitors tell me that the chain drive system is much easier to maintain. So having said that, I know that there are a number of people who have gear drive motors, and for some odd reason, or maybe it's a reason of rarity, the gear drive motors seem to bring a higher price than the chain drive motors, but they certainly wouldn't be as easy to service. Beyond that, I don't know that there's much to say about them. All right, the only other thing that there is this oil pump drive gear, and the oil pump is behind this gear. So once this particular gear comes off, you'll see there's a small pinion gear behind it, and that pinion gear drives both the oil pump and the driver for the chain in this case. And if this were a gear drive motor, instead of this part being a sprocket, it would be a gear. Another gear would be at this point, and finally the camshaft would have a gear instead of a sprocket on it, and then you would have a gear drive motor. That's really all the difference there is to these motors. The other thing to be said about this, I'll have to check and see if I can see. Yes, I guess I can. I'll tip this down a little bit, and we'll look a little bit more closely at that particular item right there. This is the output for the oil pump, and this output corresponds with something that I'll show you on the cover of the Parilla. That is where I'm touching right here. So the output is fed into this area of the cover, and that area of the cover then travels up the top to where the nozzle and quill feed are. And the nozzle and quill feed is going into the center of the crankshaft, and at the same time traveling all the way up to the oil feeds up here in the top. So, for want of a better way to say it, the little spring behind the nozzle bears on this particular piece here, and you can see that it's kind of shiny, and the nozzle actually bears on the end of the crankshaft here, and the little spring that is behind it holds the nozzle not so tightly to the crankshaft, and whatever excess oil that is being delivered to the crankshaft, the nozzle will actually come off of its seating, and the overspill will go up to the top end. So if you my guess is that if you want to limit the amount of oil to the top end, you solder up the oil nozzle and drill a smaller hole and put a slightly, ever so slightly, stronger spring behind the nozzle. Now this is the type of thing that I was talking about earlier, and if I hadn't, I've erased this a time or two. But this is the way to help remember where each of these bolts go on the cover. Now there are some bolts like this one, and this one, which just hold the clutch cover on, and I left the clutch cover with the entire left side timing cover. But it is a good idea to do this for all of those areas where you have a lot of bolts, and in the case of this cover, Each one of these, or not exactly each one, but nearly every one of these is a slightly different length than the next one. And as a natural consequence, it's really good and it saves you a lot of time if you're able to put the same bolt back in the same hole. I made a mistake here by adding that one. There is not a bolt for that area. Okay, I'm going to talk a little bit about the inside of the timing cover, and it looks to me as though this is in fact, well, let me see how I'm going to do this. Again, I'm going to try to talk a little about the inside of the timing cover. The oil comes in to the timing cover at this point, runs down this tube, lubricates a little bit of the shaft of the points. But I don't use points in my engines. I use a PVL ignition, so this particular area here for oil is blocked off and not used. Okay, so we'll start a little bit over. I'm going to try to do them both at the same time. Oil is delivered from the oil pump out this hole, delivered to this hole. Down it goes. This is the points area. This is the center of the crank where the nozzle is. And from here, the spillover oil, proceeds up here into this spindle here. I hope you can see that. Let me double check that. Okay, what I was double checking was to make sure that what I was showing was on the camera. So the spillover oil from the nozzle proceeds on up to this area of the cover. You can see how important this cover is. To this particular spindle here, lubricating the drive gear for the camshaft. So if the crank is going this way, this gear is going this way, and so is the chain. So oil proceeds up to the first gear. On the non-gear drive motors, this one is blocked off, and then it actually proceeds on up here and is delivered to the tubes that we're all used to seeing that go on up to the rockers themselves. Part of the oil that is not delivered to the outside oil lines also lubricates this spindle, and as a natural consequence lubricates the valve lifters. And the valve lifters, you want to be sure that these things are a really good, really smooth fit. And if they're not, you can see the little brass inserts here. These would end up having to be replaced. This stuff doesn't really go bad very often. I've had a lot of engines and I have never had any trouble with these particular lifters. I haven't worked on the 175s. All of my engines are 250s, so I can't speak for the 175s. Okay, we're back to the drive side of this engine, and I'm going to touch on something that I forgot to mention. And the reason that I forget to mention it is because normally with all of the engines that I have, they're race engines, and this area in here is usually cut out so that I can access the drive sprocket rather quickly for gear changes on the track. But this engine is the only one that I'm going to allow a Kickstarter to remain on it. And after everything else that was gone before is put on, this piece actually needs to be put in place. And as you can see, it's It's attached to the alignment pins for the cover. And there is room, it doesn't take up any room, so that the cover will go on here quite easily. So you want not to forget this cover. It is, by the way, the very last thing that goes on before the cover goes on. Well, okay, the next thing it looks like I'm going to do is I'm going to remove the carburetor and then take the head off. I can't split these cases until the head is up and gone, and then all of these extraneous ancillaries that are on the engine, I'll have to remove them before we split the cases. I split the cases. So we are off with the carburetor, and the next thing is going to be the 4 head bolts. Okay, I've kind of set the camera off to the side so that I don't block it, and I'll go ahead. I usually use deep well sockets for these 17mm head bolts because there are varying depths the guy has to reach in order to get all of the nuts from the head off. Okay. Well, okay, it's time for the head to come off now. And so it will actually just be simply lifted off. After one has been run for a while, the areas around the studs get carboned up. A lot of things get sort of sticky, so it's not, it doesn't come apart more often than not as easily. I've shown it here, but as I have mentioned, this motor was built, but I had never put any oil in it. So it's actually been 9 years since this engine has been rebuilt. This is going to go in the killer, by the way. So here's a little tip, and that is this keyway that's on the end of the crank. If it is pointing straight up through the barrel, then you can know without having to look inside the spark plug hole that the piston is pretty close to top dead center. Just a little trick to know. Okay, the next thing left to do is to remove the barrel. And sometimes they'll come off easy and sometimes they won't. Hang on. Okay, in order to break the barrel loose, I had to do little bits of items like this, work it around as best I could so that I could get it to be broken loose, and now, even though it won't be all that particularly easy, it will lift off. So I'll turn the camera on and you can watch me struggle. I'll do what I can to not damage the gasket surfaces underneath here. Okay, there we go. We're beginning to get it to lift a little bit. Okay, and there we go. Okay, this is one of the few of the crankshafts that I did not polish the rod, and with all of these 10 engines that actually I've got a picture of them. I'll show those to you now. Yeah, this picture is with the 10 engines, and this was taken about a year before the 99 Parilla days, and some of these engines were for different people. One was for James Britton, another one for Conway Link. The others I had built up for parts, and they've gone their separate ways, and I'm down now to the one that I'm working on now, which is going to go in the Parilla, in the Killer Parilla. All of those engines were built from more or less spare parts. There was nothing that was new, and as you might expect, they took quite a good while to do. And as a natural result of that, I didn't polish all of the conrods, and this is one of the unpolished conrods. And you'll notice here, this is one of the 4-ring pistons, and I simply dispense. I don't bother with putting on that bottom ring. Also, something else to be noted is that I always wrote whatever the size of the piston was, and it's pretty obvious that this hasn't been run because all of these markings haven't disappeared. So this is pretty much a fresh motor, and it makes life a lot easier for making this video. So the next thing that has got to happen is the piston needs to come off of the conrod, and then to make things a whole lot easier, I will remove the studs to this engine and set them aside as well. Here is a trick, by the way, before I begin to remove the piston clips. I've got a sponge rubber ball that's been cut in sort of semi-half, and what I'll do is I'll take this and stuff it down underneath here. And this way, should any of these clips get loose, I don't have to go fishing down inside the motor for them. Now, it would be moot in this case because we're going to split the cases anyway, but nonetheless it's a good practice. Okay, I have removed the clip, and it is lucky on this particular engine. It's lucky that the wrist pin's going to come out fairly easily. But there are some engines where the wrist pin is pretty darn tight in the piston itself, and there isn't a way to get back behind in order to get a wrist pin puller through. So the thing that I do is this. Well, wouldn't you know, I can't find the tool that I was going to show, but what it effectively is a threaded rod that I actually pass through the center of the wrist pin itself, and I thread a little sort of a button on the back of the threaded rod after I've taken out both clips. Now the button has got to be smaller than the diameter of the piston, yet bigger than the diameter of the wrist pin. And then I actually carve a gentle piece that has the curve of the front of this, of the front of the piston, and lay that piece against the piston, and then with a big washer and a nut, I screw the nut to where the button extracts the wrist pin. And in many cases you'll have to do something like that in order to get the wrist pin out. Okay, it's time now to remove some of the material on the drive side of the engine, and I'll kind of explain some of the functions of these things as I remove them. Okay, so the gear selector is to be removed, and that's specifically this gear here. And Good idea is to mark everything with paint or with a punch or something so that you know how this stuff goes back together. There'll be these two screws will allow this gear to come off. Okay, the screws have been removed, so I should be able to just lift this gear out. And sure enough, here it comes. I'm grabbing the screws themselves, and let's see if I can show this. Not so easy. Hang on a minute. I'll zoom this out. Nope, that's zoomed out. And then I will show how this gear is held in place. It's actually just slipped in the slot on these two screws, and this groove holds it in place. So remember that we marked it, so we want to put it back in the same spot that it came in before. This is a habit that I've just gotten in. Since this is a clean motor, I've put all of the mechanism here back in place without the gear, and that way I know where it is. Now, I don't often use air tools, but there are some places where it's pretty unavoidable. This is potentially one of them. This is the gear that is used to start the motor. There's a spring behind it, and whenever you kick down on the starter, it turns this gear on the Kickstarter, and then the clicking that you hear as the Kickstarter returns to its position is this gear. But this gear, in order to undo this nut, it's a 22 millimeter nut, it often takes a little bit of impact speed, because with a regular wrench the engine will just turn. So I'm usually pretty gentle with this, and I start with low pressure, and I have managed to crack it, but I can go ahead and take it off. And generally speaking, I try to sparingly use an impact wrench, and only for disassembly, never for assembling and torquing parts. You can't tell how tight they are if you use an impact. That hissing you hear is the leaky joint on my air wrench. But I'm now going to crack the nut on the drive sprocket, and it must be noted this is a left-handed thread, so that means I've got to turn as if I'm tightening it. And of course, if I just sit here with a wrench, this thing is going to turn, because after all, we are in neutral. So I'm going to turn this clockwise. And off she comes. Okay, and here I am with a puller attached, and I don't think this will be all that difficult. Yeah, sure enough, there it comes. And then the spring is pushing off the next gear. So I'll save all of this stuff in this order, along with what looks like, this is not a washer, it's a part of the shaft. So you can tell it's been a while since I've taken one of these apart. Good 9 years it looks like. Okay, and I know that the drive sprocket itself will take a puller, so I'm going to go ahead and put the puller on the drive sprocket. Just storing my nut here for the moment, like a squirrel storing my nuts. Okay, using the same puller for the drive sprocket, and sure enough, there it comes. I got the dropsy today, and for the time being I'm putting that nut back on the shaft so that I know where it goes. That'll have to come off eventually when we pull those shafts out after the cases are getting ready to be split. But I'll leave it there for the time being. Also, there's another note, and that is that there are a lot of bend tab washers that are to be found on various nuts and bolts, and usually I dispense with them and I use Loctite. That way I don't end up having to bend them and unbend them and this and that, but that's just my personal preference. A lot of other people stick with the bend tabs. Okay, and the last thing that will need to be done on this side will be to turn loose of the bolts which tie the two cases together. They are here, here, and here, and then of course the bolts on the outside and all underneath, but for the time being I'm just going to deal with the bolts on the inside. I'm just going to crack them and leave them. I'll probably unscrew them all the way and then screw them back. But some of these are screwed in so tight, and the Loctite has tied the nut to the stud rather than to the other side of the case. So, it won't let go of my socket wrench, so I'll have to deal with that just now. Okay, and since the stud backed out on that, and I had to put a double nut on this critter in order to get the, actually I had to take the stud and put it in my soft jaw vise, which is aluminum jaws, and get the nut off, because the nut was stuck tighter to the stud than the stud was to the cases. And now I've screwed it back in, but I'm marking this stud to make sure that when I put this back together, I want to Loctite the stud to the cases. So I'll go to the next one and hope that the stud doesn't come out with this one. It almost looks like a 9mm. That's really pretty strange. Hang on. Nope, it is a 10, and I'm just getting a better looking socket. We'll see if the stud comes out with this one. No. The stud stays in place. That's very nice. Thank you very much. And so I'll go ahead and I'll just lightly put that back in position once again, but I won't. Okay, so I've hung that nut loosely back on its stud, and I'm going for the last one. These are all Loctited in position. Boy, they don't come off either. I really do like Loctite. A lot of people don't, but I do. Okay, and that's the last of the inside one. And as you can see, I have stored that nut back on its stud. I'll remove them and put them in a baggie and label the baggie a little later. Okay, this will be just a short demonstration to show how this all works in one complete 4-stroke revolution, and that would be 2 times around the clock. The motor, this is the crankshaft here, runs forward. The camshaft goes in the opposite direction, as indeed does the clutch. And we're going to be completing one complete rotation, but only 1/2 of a rotation from the cam. So we'll have to go around again. And this time we will finally reach one complete rotation. And this is the top dead center that we're looking for when we set the engine in position to disassemble it and to reassemble it, with the cam facing down and out of the way of these lifters that are on the cover, the lifters of which push the push rods, and the push rods which rock the rockers, which push on the valves and open the valves. Okay, it's time to start disassembling this side. I've taken my impact wrench and removed the 22mm nut on this side. It's a standard right hand close, so it's not a left-handed thread. And then I will begin to approach this one. Okay, and I had to use a standard puller on it. The area where the nozzle rides is very, very hard, and so as a result a sort of a blunt end instrument bearing on the inside of this didn't hurt or damage it at all. So once it's popped loose, we hope it should come off easily. We'll see. No, it won't come off by hand, but with the puller, very gently, it will finally be extracted. Ornery critter, this one. And to be honest, it doesn't really matter where in here it is, because the key, or the key slot in this gear, I think you can see it here, yes, will be correspondent to the key that is right here. Okay, now the clutch nut is a double nut, as you can see, and I will use an air wrench to take that apart. You can also see that I slipped this gear back in place, and in order to take this this nut off, it is a left-handed nut. And you ask, how do you know? The only way that I can think of to tell you is because I told you. You have to find these things out either by yourself or find them in this video. But I will turn it clockwise to take it off. And sure enough, there it comes. Now, I don't know, what I didn't show was that I took a piece of copper here and stuck it up in the teeth so that it would prevent this thing from rotating, and that would give me a little extra resistance for the impact wrench. So I'll go ahead and I'll take the other one off as well, and it is a spring-loaded mother. The other thing is that when this is put back in place, I have to get somebody on the other side of the engine, and I have to press this really heavily with lots of muscle before I can get it started. And once I get the first one on, the second one is fairly easy. But it's not my favorite thing to do. And at the same time, it wouldn't surprise me that there's some kind of special wrench that wraps all the way around the entire engine, squeezes the spring so that you can gently get this first nut started. So now, I think I can slip this gear off, store it with its nut, and let's see, where is the other big nut for this, the double nut. Ah. That would be, huh? So I've got to go looking for it, it looks like. But here you can see. Oh, alright, I've got it. Pretty important. You know, with digital cameras, it costs nothing to take a picture. And I would highly suggest that, since it does cost nothing and you can always throw these pictures away, take a picture of what this area looks like before you take it apart, so that you can remember how it goes back together. And what we'll see is this goes like so, and there is a special hat bolt here, or hat washer, that fits inside there. So I'll stack them up like that, and then what do we have here? We have a, I'm going to bring the camera around for this. We have a piece of metal that fits in the slot here. And this piece of metal is actually pushed on by the clutch rod here, and the clutch rod comes all the way in from the other side, pushes on this piece. This piece pushes on this in that manner, and that pushes against this pressure plate and allows the clutch to disengage. So we'll take this piece out and set it with the rest. And now I have a strong tendency to take the clutch and the clutch plate pieces out in the order that they came out, and I'll set them face down just the way they came out. Until I can get all of the clutch pieces out and faced down. I even have one more here. Yeah, we've got the clutch basket. And it's pretty interesting on these 250 clutches that I better back this up so that we can see a little better, that there is a series of discs that bear on the back of the clutch outer basket. And even more important than this is that there is a series of bearings that are held together with grease only. And believe me, if this thing has been sitting for a long time, or been run dry for a while, or one thing or another, all of these little bearings are going to fall out. They're called crowded rollers, and the only way to get them back in before you can actually put the outer basket back in position is to get them and hold them in place with grease. So now I'm going to take the outer basket and I'm going to turn it upside down and set it on all of the rest of the clutch plates that I've just taken out. And now we'll see if we have any luck taking this piece off. It could be that it's going to be a little bit difficult to get it off, and that being the case, my attitude is catch all of the rollers now before you lose them. So I'm going to get a little catcher. Yeah, one of them has already come loose over here on this side, and I will take all of these rollers and try to get them all and not lose any. And inevitably, you'll find one or two that don't want to show up for you. Sure enough, there's two. Okay, so they have been caught. Let's see, there we are. And I'll just cover these up with a little paper towel so dust doesn't get to them, and go about trying to get the last bit of the clutch off of the transmission shaft. Okay, so there was an added benefit to taking the little rollers off of the thing, and that is that gave us a little bit of a lip, and we didn't have to pry from the back with screwdrivers to try to get this off of the shaft. And it's on there. And as a result, the puller is probably the only sane way that we could get this last clutch plate off of the shaft. There it is, and I'll take it, turn it upside down, and set it where it was. On all of the, in its storage position, so everything on the clutch is in its proper order. Okay, now the two wheels for the cam that ride on this chain can be removed, but it's pretty important to remember a couple of things. One of them is this. They need to be in sync with this crankshaft here. And you know that the crankshaft is at top dead center because the key is on top. It's the same as it is on the other side. So you'll get it to roughly top dead center. And then what you really want to do is make sure that you have a mark or marks on the cams. See what I'm getting at? So that when you put this back together, those teeth go in that position. And that way, the cam will be in the same timing that it was taken apart with. And if your engine wasn't wrenched on by some ham-fisted person, you'll be in pretty good shape. Now, a lot of times I like to take a carbide bit and mark the gear that is not currently marked, namely this one right here on this gear here. So I'll probably go ahead and do that after I get them off of the cases. And one of the easier things to do is to remove these two wheels. It's not so easy to get them back, but it is fairly easy to remove them. And I removed them, but I had the zoom on this thing down in this area here, so you couldn't see it. And naturally, one of the springs to the cam chain tensioners, the one on this side, when I pulled the wheels, it popped out and fell on the floor. So I figured that I would remove them, and then I'll show you the springs themselves, but they have to be removed simultaneously. And when I got to this point here, bing, one of them came out and popped on the floor. And you kind of have to be mindful of that. But there we go. And I won't even disengage them. You can, but as far as this is concerned, unless you want to make sense of the entire engine, it's just a drill that right now I could do without. So I'm going to set them down in the way that I took them off, and allow you to see how I lay this stuff out. The cam is on top, the lobe is on the bottom, just the way I took it off the engine. And you'll see on the other side of everything, all the clutch is in the order that it came off, with the clutch spring and the little pusher bar, all in the same area. Okay, so now I only have this one nut to remove to get that particular gear off of its shaft so that the shaft can slide away to the inside. I could also take off the oil pump gear, many of which you guys hear fails from time to time, and I believe Gary Emerson is making some new aluminum ones or bronze ones, and it'd be a good idea to get one if your old one looks as though it's going to fail. It's just safety wired in place. That's a square shaft that safety wire is on, and usually what I will do is pin that safety wire into the slot up above. But for the purposes of this, I don't think we really need to take that gear off, at least for the time being anyway. Oh yes, these are the two springs that fit up here in the cam chain tensioner area. One of them here and one of them here. And these are what spring out. For want of a better term, I call them cone springs. You can perhaps see why, because they're flat, but they're round in a kind of a cone, so they spring up and down in that fashion. We've always been looking for another way to design this cam chain tensioner phenom, but nobody's come up with anything successful today. Okay, and the last gear to be removed before the cases are split is going to be this gear here, which is the crank timing drive gear. It drives the oil pump, and it also drives the camshaft. This one could prove pretty ornery, so I'll show you what ornery is like. No, it's going to be nice. Alright. Now I'm going to have to remove the key, which you can see here, before the nut will come off. That's easy enough to do. Okay, the nut is off after the key was removed, and there's a lip right here designed for a puller, and so that same old trusty puller, I'm going to use it. Okay, it appears that particular pulley is a little bit too klutzy for this gear. The teeth on the side of the puller, they won't decently sink in there together. So I'm going to have to either regrind the hooks on the puller or use another puller, and since I've got another, I'll go ahead and do that. Okay, as it turned out, the other pulley was klutzy as well, so I had to go back and grind a little bit on the jaws of this one so that I could get it to grip this gear enough so that I could put a puller on it. Okay. So now we will seriously push. Oh. Well, this gear is going to be particularly ornery. It may be that I end up having to heat it, but we'll just have to see. Okay, since I did decide I was going to have to heat it, I decided to remove the oil pump gear, and you see the oil pump behind it, so that I wouldn't burn that fiber gear. And now I'm just going to try to cook this thing. This is, by the way, under tension now. So if we get it warm enough, perhaps it will swell and turn itself loose. Be nice. I'm using MAP gas instead of acetylene. It burns a little bit hotter, and I'm hoping that I will be able to succeed with this by using the MAP gas rather than oxyacetylene, because that is way hotter. It's hard for me to remember all of these engines because they were all built in one go. There we go. See that? Just popped loose. Glad you got to see that. Okay, I've removed the gear, the Woodruff key that the gear resided on, and the only other things that there really is to do is I can remove the transmission by taking this cover off, and I'll go ahead and do that. But beyond that, the only thing left really is to split the cases. Now, the oil pump is still in situ and it runs free. I'll show you a little later on what an oil pump looks like. In fact, I'll talk just a little bit about this one now. There are two threaded holes right here and right here, and they are 6mm by 1.0 threads. And if you were to take loose this screw, and this screw, and then take two 6mm by 1.0 Allen heads that are fairly long, put them in these two holes, and gradually turn them, if not both together, half a turn at a time on each one, they will pull the oil pump out of the case. It's press fit into the case, and it also helps to align the case a little later on to make sure that you put these screws in, make sure that you take a picture of everything. And you'll probably see here that I've indexed, let me see if I can show this. I've made an index mark right here with a chisel and right here with a chisel, so that there's no mistake. This is how this thing goes back together. And the The only other thing to say about oil pumps is they either work or they don't. And if they are working, leave them alone. And if they're not, get another one. Okay, it's probably time to take off the transmission cover now. It does have a gasket on it, but really the gasket isn't needed to be sealed per se, because after all, this is the wet side of the engine. So any oil passing through here, or here is going to lubricate whatever bearings are going to be there, and at the same time not go anywhere else. Okay, a little tapping and the cover is ready to come off. And I'll put the cover face down just like normal. Now you remember this transmission is in neutral now, so it ought to be relatively easy to just tickle everything out of here. We shall see. Now what fell was one of the keys to one of these shafts in here, so I'll have to kind of make a note of that. That key will be put in the transmission area. Okay, as I'm beginning to tap the transmission out, I notice there is this sleeve here. And this sleeve is designed for the Kickstarter mechanism, which I never use. And for me, it is a slight, if mild, surprise. So I'll do what I can, if I can do it gently. No, I guess I can't. To remove it, so I'll continue to tap and see if I can't get it to behave itself and come out peacefully. I don't know why it's sticking. But it sure is tight to the shaft. And I'd rather it wasn't. Okay, so this piece ought to go with the outside of the motor. And if I read this correctly, it should be sliding into that spring and going like this. Actually like that. Stuff fits awful tight. I'm going to have to work on that. Anyway, it's now in its proper place, and this transmission now should behave itself and come on out. Okay, there's one. 2 and 3. That's pretty much the way they go. Okay. And now as we look inside, we'll get a chance to see something that was kind of a mystery if you look and try to change the oil down at the bottom. And that bit of a mystery is, oh, sure enough it snapped on out because it's got a spring that is underneath it. This is the detent. That thing is what keeps the transmission in a gear. And whenever you go to switch to another gear, it pushes that down and it rides in the down position until it gets next to or near the other gear, and then pow, it comes back up into the slot into the shift drum down here and holds the transmission in the gear that you selected. Okay, it looks as though we are now ready to take the cases apart. There's really nothing inside. You notice I've got these rubber bands here keeping the rod from hitting either side, nicking the rod or nicking the side of the cases. But we'll take it apart anyway and show you more or less what isn't inside, other than the crank itself, because everything else is gone in there. But it'll be nice to see the inside of one and how it comes apart and how it goes back together. So I'll begin now by taking off the stand, laying it down on its side, and starting to take all of the little bolts that tie the two cases together. I'll go ahead and do that now. Okay, now as we should be able to see, I missed a few of these earlier when I took this apart, and the ones marked in red, of course, are the ones that I've got to put back, make sure that the studs are Loctited into the cases. And then we've got this, and we'll have to check on the other side and see what we've got there. So I'll go ahead and do those now. Okay, I'm going to do this the quick way. Remember, undoing is all right, but I wouldn't do things up with this method. I got the dropsy again. And again. I've lost the ring from my small impact wrench, and naturally everything drops out. 9mm. No, it's a 10. I'll use two 10 box ends. Don't quite know why it's missing, but missing it is. And the drop seal again. Okay, well, I think you get the idea. I'm going to go ahead and organize these bolts in a way that, well, I'll have them put back in the same place that they were in before. Okay, if I didn't show this before, I'll show it now, and that is I laid it on a soft blanket and gave it one hell of a whack, and the cases came apart, and now it's just a matter of fidgeting and jimmying and doing what I can to get the pieces to come loose. Okay, I jimmied it to where it's almost apart, and now it is. And we can sneak a look in here. At least I think we can. Okay. And as you can see, there really isn't anything in here to speak of. And I probably, at this stage, won't go any further. We can talk about splitting these cases, or talk about splitting these cheeks, but it is a fiddly thing, and if you're a semi-amateur mechanic, I would strongly advise you to separate these cheeks, have these done by an authorized mechanic. You may notice that there is no nut here to hold the crank pin. In fact, I am actually touching the crank pin. This aluminum piece here, let me see if that's actually being able to be seen. Yeah, I'll swing it around. This aluminum piece here is to block the oil from coming out this side, and the crank pin itself is drilled in such a way that the oil will come out of the middle of the crankshaft where the rod is. So there's another thing that we have here. I believe one of the manuals says that there should be a 1.5 thousandths interference fit between the crank pin and the cheeks. To explain that, interference means that the crank pin is 1.5 thousandths bigger than the hole that it is pushed into, and that way it sticks and stays, so the metal is pretty well stressed. We're personally of the opinion that it's probably closer to 2 thousandths, maybe even 2.5, but the manuals that I have seen anyway say that 1.5 thousandths interference fit for the crank pin is just about right. And the only other thing that there really needs to be done is the crank pin needs to be aligned to, I'm talking about the other side of this, it needs to be aligned to the other side of this pin where the oil goes in. It goes in and it actually turns a 90-degree corner and is delivered to the crank pin. And this is how the oil gets to the rod. So other than that, the only thing that there is perhaps to say is that you, let me see if I can, yeah, this material here, it's a gray material and it streaks off, will actually melt with lacquer thinner. It's called Yamabond or Honda Bond, depending. And in this particular case, I have chosen to use no gasket. And the reason for that were twofold. One of them was that I found that with no gasket, the rod as measured by machine tools was in the center of the barrel hole, this hole here. And the other thing is that without a gasket, there was only 10/1000ths of an inch back and forth play of this crankshaft inside of the cases. And 10/1000ths is about all you want. So what I should probably do for the amateur mechanic is talk about things like this. This is a dial caliper, and they're relatively inexpensive these days. You can get one of these from Harbor Freight for around 25 bucks. They're really essential for building motors. You want to find out how thick something is? Well, you just read it off of the dial. If you want to find out how deep something is, you just read it off of the dial. If you want to find out how big a hole something is, you read it off of the dial. It's a terrific, and I believe an essential tool for working on any of these engines, on any engines anywhere. And as a result, my very high recommendation is to get one of these, learn how to read it before you start opening up a Parilla engine. So what we can do, let's see, yeah, it looks as though there isn't really dirty in here. It looks dirty, but it's not. Anybody's guess as to what this set of engine cases has gone through before I got it. But this is some kind of a patina. It's not dirt because I can't move it. Here's the other side of the oil pump. And by the way, this is the only oil filter that a Parilla has. And it's another way of saying that if you're smart, you will change the oil in your Parilla often. And really what needs to be done is that particular piece, there's a bolt on the other side where my finger is. You can unscrew it and literally pull it out, wash it off, put it back in, and change the oil again. But if you want to keep your Parilla going, most all of the Italian singles have only this system. And as a result, if you want to keep your bike going, change the oil often. Okay, so now I'm going to lift the crankshaft with the rod in tow out of the cases. So you can see completely what it is that's under there. Virtually nothing. The back side of the oil pump shows you nothing. There is a hole here and a hole here for oil to get through into the timing side of the engine. And that, once again, is a good reason to have a good seal on the timing cover. So we'll go have a look at the other half now. I'll move this one and bring the drive side half into play. You probably recognize that side, but now we're going to have a look at this side. These are the transmission bearings. You can buy these anywhere. This again is the detent that I showed you. This is what holds the transmission in its gears. I'll see if we can see this. This is an engine case alignment pin. And so is this one. These are the two big main alignment pins. This is a bearing race. The other half of the bearing is over here on the crankshaft. Not too much else here. This is where the dipstick comes through. Pretty simple once you get it right down to its bottom. And so tomorrow and for the rest of this video, I am going to talk about what's involved in putting this engine back together. And there will be more things to be learned along the way, but it's going to be more than anything washing everything clean, making sure that it's really clean and that it's got a light coating of oil on everything so that it doesn't rust before you get it all together. A3, and we're going to set about putting this critter back together. And one of the things that we're going to start doing is by removing the Yama bond or Honda bond that is on the cases here prior to cleanup, and we're going to use Napa's gasket remover to do that. And so I will spray that. Now this will curdle up. See if I can see a little spot. You can see it kind of bubbling there. And this will allow it to just be wiped off. It's pretty nice. The other thing that I do on a number of cases, if the cases are particularly dirty, first I will take and scrape as much of the grease off of the outside of the cases as I can, and then I'll take the whole case and dip it in a 25-gallon, well, excuse me, a 5-gallon bucket of Chem Dip. I believe it's a CarQuest product, and it's somewhat expensive. 5 gallons will cost right around $70, but boy, it's worth its weight in gold. When I first got the double overhead cam Parilla, it had 40 years of grease on it, on the inside as well as the outside, and honestly it was really a miserable sight. And Bruno Beccari, the Mr. Parilla from Italy, well, the spirit of Mr. Parilla, from Italy anyway, has the biggest museum in Italy, told me that I couldn't bead blast the cases because it was a historical artifact. He told me that I had to go over the cases with a toothbrush. Well, I didn't think that was going to happen, given all of the little ins and outs of it. So what I did is I went down and I bought a 5-gallon can of this CarQuest Chem Dip and separated the cases, pulled all the studs, dropped them in there, and left them in there overnight. It's kind of like a carburetor cleaner, but it's not the type that will eat the aluminum like some of the Chem Dips will do. And when I got them out and sprayed them off with another type of carburetor cleaner from CarQuest, I sprayed them off with this material here, and they were so clean, there wasn't a scratch mark on them that I had made. There were plenty of scratches on it, don't get me wrong there, but after banging around for some 50 years, the cases on this bike came out looking like a baby's bottom. It was wonderful. And that's the way that I really like to clean really super dirty motorcycle cases. Some of you may be aware that Yamabond or Honda Bond is pretty tough stuff, but as you can see here, it's just bubbled and boiled up from this gasket remover, and it will actually, if you scrape off the majority of paper gaskets and then spray gasket remover on it and let it set for a little bit, boy, it'll come right up with a blade. Okay, I'm going to normally I would have a sofa back over behind me, and I'd lay a big towel over my lap, and then I could work on each one of these pieces, trying to get them as clean as possible and free of the gasket remover as I could. But my wife has run off with the van, and the van seat was what I use normally here in the back. She's got a big bunch of company, and so we had to put seats in the van, and I am now bereft of a bench seat where I can set this stuff in my lap. But that's okay, we'll work on it the way that, with what we have here. Okay, I've cleaned off most of this case, and I think you can probably see the shine. There are some casting imperfections like in here, and as a result, the Honda Bond, I'm going to call it because that's what I use, will fill those in quite nicely. Now, as far as bearings are concerned, it's probably a good idea to spin the fingers, even take them out, and the best way to take them out is to put the entire case in the oven, and generally if you bring it up to about 350, 375 degrees, the bearings will pretty well fall out, and putting them back is even easier. Generally, if they don't fall out, you need to turn them over to the other side and get a shaft that will actually fit from the other side and drive the bearing out in this direction, and they'll come out fairly easily. As far as putting new ones in, it's pretty easy to heat this up again to the 375 degrees in the oven, and put the bearings in the freezer, and they will shrink a little bit, and right you just pick the bearings up and drop them in, and boy, they usually drop in pretty easily. If they don't, you need to have something there to drive them in to where they're flush or down at the bottom of the bearing pocket. Also, as far as getting things really clean around these great big alignment pins, which is what these things are, push come to shove, I remove them, and then I clean all of the surface and make sure that it's really nice. I don't sand on it because then the cases will be closer together and it will change the tolerances as to how the crank, what kind of end plate clearances the crank has. So you can pull all of these alignment pins, the small ones and the big ones, and get everything really nice and clean, and then go ahead and put them back in. Now, as far as the seals go, I was right. These 3 seal areas, they are all the same. They're 20 by 30 by 7, meaning 20 millimeters by 30 millimeters by 7 thick, inside, outside, and thickness. And I had a look at this one, and it didn't look very good to me, so I decided to knock it out and put another one in, and I will replace that with a bushing driver so that it goes in uniformly. I'm showing you here that it says 20 by 30 by 7 on the seal itself. Okay, I've positioned it above the hole. I'm using a bearing driver to fit down in the hole, and I will just drive this to where the bushing is flush or a little bit below flush. Okay, it's been driven in, and as you can see, it's peeled a little bit of the outside of the bushing, so we know it's a good fit, and it's just a little bit below flush, 20 by 30 by 7. Okay, back to the inside again, and I'll just put a little bit of oil in each one of the bearings. I'll put a little on my fingers and wring the seals a little bit to prepare them for the shafts that will be going through a rather tight oil seal. Okay, I'm removing the bottom bolt that pushes on the spring for the detent, and as you can see, as I screw it in, the detent will gradually get higher and higher. Now this explains why I had difficulty getting the transmission to come out of the cases before I split the cases. I'd forgotten about this, but that's okay. I'm old. I'm allowed. Okay, and these are what these pieces look like when they come out, and I advise you strongly to leave them out until the transmission is in place. And one more thing, I've taken number stamps and I've stamped TRNS for transmission on this bolt, because when you get this all together and you look at both of those bolts, like the old guy that I am, I end up thinking to myself, well, which one is the oil drain hole? And if they're stamped, there's no doubt about it. By the way, this is a 22 millimeter bolt, and there are a lot of bolts that are fairly odd sizes, metric, on Parillas. Jack mentions to me, he says, who the hell ever uses a 22 millimeter socket? Well, Parilla does, and they use a lot of other pretty strange sized sockets as well. Well, maybe not all weird bolts, but certainly enough. Now what I'm going to do next is I'm removing all of the studs, these little short studs, so that I can clean this side of the case really good. And the way that I'll do that is I'll put 2 nuts on the end of the stud, cinch them together pretty well, and then just unscrew the whole stud. And I do that like so, and then I'll just cinch them together and unscrew. By the way, Honda Bond, its solvent is lacquer thinner, and lacquer thinner will clean up Honda Bond or Yamaha Bond pretty quickly, particularly after you've sprayed gasket remover. Okay, this is the oil drain hole, and as you can see, I have number stamped or letter stamped the word oil on here, so that when you get down underneath here, it's easy to confuse these, and a guy begins to wonder which one is which. Well, there's no doubt with this. Okay, the surface of this oil drain hole, the area where the fiber washer bottoms has been cleaned, so now I can put the oil drain plug back in place. Okay, it looks as though this side is ready to have Honda Bond put on it. Looks dirty on the inside, but believe me, it's not. There's some material embedded in the casting there. So I'll go ahead and put the Honda Bond on it, and after that I will Loctite in all of the studs. That way I can get the Honda Bond nicely around all of the meeting surfaces. I try to keep this stuff off my fingers, but I don't always succeed. And what it amounts to is doing that and then coming back with a paintbrush, a small one, and spreading it around. And I'll do that all the way around the mating surfaces of this set of cases. Okay, now before I put all of these studs back in the cases, I'm going to clean them up, and with some luck they will look very, very different. Okay, this will give an idea of how cleaner bolts look. The last couple here are not clean, and I'm going to show how I do clean these up. Actually, I'm removing the Loctite from the last installation on these. They're pretty clean, as I mentioned, but what a guy would want to do, you can do this, what I'm going to show you, with the dirtiest, greasiest, scuzziest bolts around, to bring them up to a standard where you know that the torque settings that you put on these things are going to work. Okay, I'm going to take this bolt in this cramped little shop of mine, and I'm going to go in and actually demonstrate a bit as to what I will do with a bolt like this. This is a wire wheel. Now I can't really show because it takes two hands to do this, but I'll work over the entire bolt, and then I'll put the nut on, and I'll polish up the nut as well, or just wire brush it on not only the outside surface but on the two mating surfaces. And when I'm done with that, I'll take the nut back outside where I've got a tap waiting. I'll see if I can do this without cross-threading it. And I'll run this nut down on, as it happens, this is a 6mm by 1.0 tap, and I'll go ahead and take that off, and then I'll take the bolt itself, it's on another setup here, and run a die down the bolt. And as it happens, this is a pretty good looking bolt, and so the die is just a check. But on some of these bolts, I'll actually have to use a wrench, and as you can see here, there is a little bit of metal from some of the past bolts that had kind of buggered up threads. This one's pretty good though. Okay, and then I'll call these clean. Okay, and I should mention that the reason for the double nuts on all of these here are these studs are going to be installed. This end here will go on the cases, and then one of the nuts will be, well actually both the nuts will be removed before I close the case. Okay, it has occurred to me that for the first time builders of motor Parillas, it would be a darn good idea to install each of these studs, the inner studs, and you see that they, well, almost all of them have double nuts, and I'll put the others in a minute. But the reason that I use the double nut is to screw them all the way to the bottom. I'll put the others in, then I'm going to take the nuts off, and I'm going to put the case empty of anything in position to make sure that all the studs come through far enough that you can get a washer and a nut on them. Okay, all the studs are in and moderately cinched down, and the double nuts have been removed. Why do I do this? So that in this case, this particular stud over here is shorter than all the rest, and sometimes all the studs that you get they vary in length, and we want to be sure after we drop the other cover on here that they all end up being long enough to get studs and washers on, as I mentioned. So I'll put the other cover on here, and if everything looks jake, then I'll pull it apart, take the studs out, and then I will butter both cases with Honda Bond, then put the studs in with Loctite, and put the transmission in on the other case, not this one, and I'll put the crankcase in on the other case, not this one, and lower this case onto the transmission and the crankshaft. Okay, I put the other half of the cases on, and it looks as though each of the studs is going to stick through nicely enough to get a washer and a nut on them. Why do I do this? Another reason is that many times you'll find some of the studs are bent just a little bit, and it makes it very difficult to get the two cases closed. You need to find out which stud is bent and straighten it, or get another one. This is not the kind of thing that you would do if you were a pro. You'd make sure that you would have all this stuff straight in the first place. This is for the new time build. Okay, the buttering is done, as you may be able to see here, and the studs are due to go in next. As soon as they go in, then everything is propped up, the crank goes in, the transmission goes in on the other case, and then we will close it with this. They're in. The nuts have been removed, the excess nuts, and I'm now daubing up the last of the Loctite, and what I use is 290. Some people call it a Wiccan lock, and others call it Loctite green. It's the toughest of all of the Loctites, and it's a way of saying I don't want these studs to come out. Okay, both sides are buttered and wet, and now the crank goes in and the transmission will go in, and then I will close this with the other side. Okay, the crank is ready to go in. Remember that the double key side goes toward the timing side, which is not the one we're putting in, so we'll put this side. There it is, and now the transmission's next. And now the transmission is in place. Took a little fiddling this time, but you know, sometimes this happens. Okay, now the cover is on, and what I'll do is I'll take and put a couple of these outside bolts on so that I can turn it over and put bolts on the nuts on the other side and cinch them up lightly. Okay, the only thing that remains now is the transmission cover, which I'll put on, and then I will put on the engine stand blocks so that I can stand this thing up. I did forget to mention that when you torque these bolts down, you want to torque them from the middle to the outside. Go 1, 2, 3, 4, 5, 6, and so on. The same with the studs that are on the inside. Now it has occurred to me that I've skipped by something that I already take for granted, because I do this when the engine with the crank in it has been assembled, and the two cases are not glued together, so to speak, for want of a better term. And what is done is measurement is taken to make sure that the rod is in the center of the hole down there. This is one of the devices that is used. This is a snap gauge, and this snap gauge is put into the rod and checked to see exactly how far it is from the hole on that side. And then the snap gauge is measured by our trusty dial indicator. And as it turns out, on both sides of this rod, the distance from the edge of, or the inside of the rod to the hole is 1.412 inches, which means that it is satisfactorily in the center of the hole. And finally, a person wants to check to make sure that both the rod and the transmission are free before torquing everything up and after torquing everything up. Okay, so I think the next order of business will be to build up and reassemble the timing side of this engine. And to do that, I'm going to pull the engine cases again, or the engine stands again, and lay it down on its side for that rebuild. The word I should have used was reassembly. Rebuild is quite another thing. Okay, here we go. The first thing I want to do is put the clutch together. Here is the clutch upside down, and we'll see that this gear this shaft kind of flops around in here because it needs this particular spigot to ride on the bearing, and as you'll see, it fits in a splined manner like so, and now there's no slop in that shaft. Next thing to do is going to be to grease this edge area here and put all those needle bearings back in place to accept the large clutch basket, which is right over here. If it'll focus, yeah, there we go. Okay, this is not so easy to see, and the camera angle is a bit awkward, but I want to show you just how awkward this exercise can be. I'm pulling these needle rollers out of this little pan that I stored them in. And one at a time. I don't know how many of these things there are, but they have to be packed all the way around here. Awkward is the quintessential word for them, and as you can see, I'm ending up dropping some, and I don't want to drop them inside the motor, definitely. Okay, well, I'm going to continue on here and show you what it looks like when they're all in place. It's not the most graceful job anyone can do, but this is the finish of it. And you will see here that I have left one bearing out. Actually, there wasn't a bearing to go there, and that's the way it's supposed to be with a crowded roller system. Always leave one bearing missing, and that'll give it room to go through the ebb and flow of the kinds of things that these needle bearings have to do. Now, this is a caged needle system where the needles are held in a cage and their spacing is kept constant. So this is the other way to solve that problem. This is not the application for that clutch, but the needles are the same diameter and the same length. This is used either for the cam or for the driver for the chain or gears for the timing system. Okay, with all the bearings in place, we'll now go for the outer clutch basket. And we want to fit it gently so we don't dislodge the needles. Just kind of delicately drop it down. And there we go. And as you may be able to see, I think in the viewfinder I've got them both here. The clutch plates go in the same way that they came out. In the same order. Now, this won't end up being as simple as it looks, naturally. In fact, I'm going to take the whole block of clutch plates and pressure plates, just turn them up and turn them in. Okay, but you will see that because of the inner clutch basket, which is this, that this is not going to drop down as easily as one might like. It'll drop down to the first ones, but then you'll kind of have to jimmy and fiddle around to get the second ones, and so forth and so forth and so forth, until this piece goes all the way down. I'll go ahead and do that now. Okay, I finally had to do this another way, and that was to turn the clutch upside down, just the inner clutch basket and the pressure plates and clutch plates themselves, and hold them in position, and then, I hope you can see this, and then drop the outer basket all the way down. Then turn it over and very gently drop it on to the shaft. And there we go. Okay, so the next thing is going to be to install the little bar that allows the inner clutch basket to release on this pressure plate. It's not the most positive way to pull a clutch apart, but it does seem to work. And then the hat with a hole in it. And after that, on the 250s, they are quite different from the rest of the clutch world. But usually the best way to approach this then is to just install the barrel nut, and just get a few threads on it, then put the spring in place. You see this has got a spigot, so it'll reach down in there and get a hold of the barrel nut. But you have to kind of put your hand in the middle to keep the barrel nut from rotating any further down. Okay, now that's just going to keep the clutch from coming apart as I tip it up. And even though we have a lock nut here that is designed to go on top after the spring and everything is screwed down. I'm going to leave this off for a minute. Okay, I've tipped the motor up so we can see it a little bit better, and I'm going to assemble this by putting this gear on first, which is the main drive gear. I've already put the Woodruff key in place, and you might be able to see that it is pretty level there. If it's not level, the gear won't slip. Okay, the gear is on, the nut is threaded, but I'm going to use, in a rare occasion, the impact wrench to cinch this down. Not too tight, but I will Loctite. Okay, the nut is cinched down. I'm just going to put a little Loctite on it. This is Wicken Lock or green Loctite, and it runs and penetrates by capillary action inside between the nut and the shaft. It's wonderful stuff. I like it. Not a lot of people do. Okay, I've slipped the cam wheels on with the chain on, but you may notice that I don't have, where the heck are they? The springs. Yeah, here we are. I don't have the springs in place. And this is one of the, I've used this piece of clay to hold that one cam chain tensioner shoe in place so that I would slip this on. This is one of the more unpleasant things a guy has yet to do to get a Parilla together, because once I put the springs in, it's a real fiddly job to get everything, get the teeth lined up as per down here, and as you can see that I have marked it. And the red dot up here is straight up top, and the cam lobes are as close to straight down as we could get it for the moment. Okay, it's time to put in the cone springs. These are those which have a tendency to fall out a lot. So what I'm going to do is I'm going to take this cone spring and dip a little bit of it into some of this Honda Bond, so that when I put it in its place, allegedly it'll have a tendency to stay there. Okay, it took a bit of jiggery pokery, but as you can see, the cam chain tensioners are in place, and the gear is again mated with its one on below, and up top the cam is pointing straight down. Okay, and the next to last gear is the oil pump gear, and it's being put on, but I don't have, let's see if I can get in close, I don't have a cotter pin small enough, and so what I'm going to do is use a little bit of spring steel, and I have to bend both ends up and clip them off. And by the way, that hum you hear is the heater going on over here. Today it's turned out to be pretty cold, so I've got the heater going. You'll just have to put up with it. Okay, so much for safety wire. I did have to, for small cotter pins, which I didn't have, I finally went back to safety wire. I hope you can see that. And now for the final gear. The Woodruff key has been put in place. And I'll see if I can get this on. It takes two hands. Yes, it went on pretty easy, and now I'll go get the nut and torque it down and Loctite it. Okay, so other than tightening down the clutch, getting the clutch compression spring down tight, and the extra jam nut in place, the timing end is pretty much finished. I will say this though, that I'm not going to butter and close the cover. I will put the cover on, but I'm not going to butter and close it until right at the last minute, because I want to make sure that we've got the cam timing exactly right, and if we have to do some major adjustments, we'll have to deal with these these two wheels. They will actually come off the inside gear without tangling with the outside gear, and then you can shift them just a little bit. But I want to make sure that the cam timing is right before we go ahead and butter this side and make sure that it doesn't leak. Okay, I've had to use the impact wrench on the inside big nut because the clutch has a tendency to want to spin. So I ran it and the barrel nut all the way down. Then I grabbed a hold of the inside nut, and the barrel nut exposed a smaller nut. I don't know if you can see it here or not. Yeah, you can see it here. This is a flat, and I actually backed off the barrel nut maybe as much as 100 thousandths to give room for the clutch to come out and turn loose. Then I went ahead and held the barrel nut while I continued to cinch the inside big nut, and when I was happy with it being fairly well down, then I went ahead and I put the jam nut over the top of that. I'm not going to cinch those up real tight right now because it remains to be seen whether or not we'll need some further clutch adjustment after we get everything together. Now the last thing is going to be to put the cover on. As I mentioned before, I'm not going to seal the cover yet. I'll go ahead and put all the bolts in and more or less button it up, but I'm just going to have it available to be removed so that if I need some cam adjustment or some clutch adjustment in a major way, I'll be able to affect that without having to break the seal. You will likely recognize this as an interior case gasket, and this and all the rest of the gaskets are the same thickness. They are 10 thousandths of an inch thick. To show you what I mean by that, I've got this one in the grip of my dial indicator, and as you can see, it is 10 thousandths thick. And as you might expect, the timing side gasket is the first one that gets used, gets torn, and you have to end up buying a whole other gasket set in order to be able to replace it. So what do? They think I'm pretty strange, but I go down to the art store with this tool and I start looking for paper that is 10 thousandths of an inch thick. And I bring it back, glue them onto one of the surfaces once I've determined that I've got a 10 thousandth thick piece of paper. And after they're glued on and set, I cut out the outside and cut out the inside, and I've got myself another gasket without having to buy a whole gasket set. I have a little time left before I have to wrap it up for today, so I'm going to show a trick that I use for a seal that I don't keep having to rebutter and rebutter every time. It's been my experience, particularly with track bikes, the Parillas, these valve covers have to come off fairly often. If you're going to get the head off, they got to come off because you got to pull the rockers and push rods. If you want to just get the cover off, rockers and push rods got to come off as well. So this is a little trick that I use, and it's worked out pretty successfully lately, and that is this. I take polyurethane rubber and glue it to the bottom surface of the valve covers, and then I take the valve covers and I set them down on the saran wrap. Now for some reason saran wrap doesn't like to be bonded with polyurethane rubber, so I'll go ahead and take these off and show you what they look like. Naturally I've got to start the camera and then run around to this side so that you can see. And all I'm really doing here is cutting the saran wrap. And sure enough, these pieces will come loose pretty easily. I'll give you some close-ups. I'm going to have to actually trim them, both on the inside and on the outside. But I'll give you a little bit of a close-up look as to what this surface looks like. This is a pretty good seal. The nice thing about it is you can slap it on the top of the engine, tighten down the Allen heads, and the next time you need to pull the rockers, or you just undo the two Allen heads, pull this off, and there's no resealing to be done. It's pretty nice. Okay, it's back up on the pedestal. It's a little bit easier to film from here. And I don't need to put the bolts back in just yet because the alignment pins are going to hold this in place pretty well. And I'm going to go ahead next, which will probably be tomorrow, and rebuild or reassemble the other side, namely the drive side or the dry side, whichever you prefer. Okay, now we begin on the drive side or the dry side. I kind of like that. You may recall that this particular piece, which the spring fits around, was rather difficult to get off. I took some 400 sandpaper and I cleaned off all of the burrs on this, and I ran a little bit of lacquer thinner and a rag on this, and it fits the way it was supposed to. If you don't recall that, you weren't paying attention in the first place. Haha. Okay, so this is the order that they go on. The spring, the gear that has no bite in the inside, but with the ratchet teeth on the outside, and then finally its mate with the ratchet teeth, and the 4 splines which will engage on the end of the shaft. And here we go. The spring, the gear with nothing on it, the ratchet teeth facing out, the other gear onto the spline, and a nut. If we can get it to thread straight. And yes, we can. This is all for the Kickstarter mechanism. When the Kickstarter is released after you have kicked it down, this is how it comes back up with this ratcheting motion. So it'll go in one direction, but it will not go in the other. Okay, and the next item of business is the key for the transmission. And you can see this shaft is free because it's in one of its false neutrals or in a real neutral. We'll find that out in a little bit. The key is here, and I will go ahead and press the key in to start. Then I will use my fantastical German wrench to place the key exactly the way I want it. I'll show you about this German wrench. It's a wonderful piece. But now we are ready for the sprocket, and then we will be ready for the washer and the nut. Sprocket is next. And may behave, and then again it may not. I'll have to fiddle with this a little bit. And this is what I am calling fiddling. Okay. Now here's a danger that you don't often see, and that is this, and I hope this will show, but the key back here in the back, yes, the key back here in the back has rotated out of position, and that means the sprocket's going to have to come off and the woodruff key is going to have to be reseated. So now with the sprocket gone, you can see what the woodruff key has done. We'll have to reseat it and make sure that everything, the sprocket slips on without dislodging or changing the position of the woodruff key. Okay, a little light massaging on the key, and let's see what else have we got here. That's really about it. Okay, now there's a special washer that it's a good idea to use when pressing this down. You may be able to see that this, let's see if I can point exactly right to it. This area here is the shaft itself. This area here is the sprocket. And you may be able to see that the sprocket is further in than the shoulder of the shaft. And that needs a particular type of treatment. And even though I'm going to clean this up, I'll go ahead and show it to you. This is a washer with a slight recess. And I turn this recess face in so that the shoulder of the shaft can protrude through and not keep the sprocket from going hard home on that taper. Okay, the washer is cleaned up. Its recess is deeper than the shaft sticks through, so we know that with the nut in place. By the way, once again, this is a left-handed nut. The nut will press on the washer, and the washer will press all the way on the sprocket and not press on the shaft at all. It'll allow the shaft to come through, and that way the sprocket will be pressed hard onto that taper. Okay, the nut's down tight, and looks as though the only thing left to do is to set up the shift mechanism. And you will notice that without the detent in the bottom with the spring and that plunger, we're able to shift gears pretty easily. So I will try to position it back in that neutral position and then go ahead and put on the fan shift gear. Okay, well, it can be seen that we're in a false neutral right now and not the real neutral, because if you recall, the real neutral should mesh with this gear. So we'll end up having to turn the shifter, and when we turn it, sometimes we're lucky and it'll just go down, but then other times we won't be able to turn it at all. And you see what I'm doing is I'm moving the sprocket to allow the shift dogs to be in a little bit different position, and then we can have a shot at having these gears mesh. That's not quite what we want, so we'll turn it a little more, and now these gears are going to mesh just fine. So now I can remove this gear and put all of this mechanism behind the gear, screw it down, and we will call this side pretty much done, except for the fact that we're going to install a PVL ignition system on the crank over in here. That's going to be a fairly involved process, but I'll show you the test system that I've set up for my PVL systems. And anybody interested in CDI ignitions, which by far are the better ignitions, if anything could be said about Parilla and most of the Italian motorcycles back in their day, the worst thing about them was their ignition systems, and when they quit on you, it was because you lost spark for a myriad of reasons. And the CDI systems these days change all that. So if there's any possibility of putting a CDI system on there, even on your street bike, get a hold of Bob Moon or Mike McGarry, and they will be able to put you together with the best ignition system you can possibly imagine that also will produce enough juice for your battery to run the lights. Okay, and the last thing that I forgot on the last assembly was this cover. And the reason that I, as I explained, never use this cover is because 90% of all the motors that I have do not use kickstarters. So that little cover goes on, and then all of the prep for the actual cover itself is supposed to go on there. That's enough for today. So now I'm not going to put this cover on. I'm actually going to take all of the cover material and put it aside in a box, because the next thing to be done is to begin to assemble the top end, and we're going to need access to be able to turn this rod in order to get everything just right, and that will be next, and I'll start that tomorrow. Good morning. It's the 18th of May in the morning, and I am hearing a rather unpleasant whistle in some of the last of the audio, and unfortunately there's not a lot I can do about that. This is an amateur video after all. If we had a team, that would be another thing. Okay, what I'm going to do today is I'm going to show how we can make sure that the piston has enough clearance between the piston top and the head. And the way that I'm going to do that is I'm going to remove the rings on the piston first. Then I'm going to put the barrel down with no gasket on the bottom and a thin gasket on the top, and put a bit of clay on the piston, and then run the piston through its cycle with the valves closed, and we'll see just how much clearance there is between the piston and the combustion chamber. Okay, the piston has been temporarily installed, and you notice that it doesn't have any rings. And now I'm going to go ahead and put the barrel on, and there is no spacer on the bottom of this barrel. And you'll also notice that, let me show here. Yeah, that the key is pointing it straight up through the engine, so we're at approximate top dead center. So now we'll do what we can to get the barrel to sit down. Don't know what's going on there. Hang on a minute. Okay, a little tap with a dead blow hammer, and the barrel sat down. Probably it had to do with the fact that there's a little bit of spillover gasket material, the Honda Bond, on the inside. I'll clean that up so that it'll move nicely. Me and my allergies. Also, I figured out what the sing is, and that was a feedback while I was hanging the headphones on the camera. Can't do anything about it in the past, but I'll eliminate it in the future. Okay, so the piston is now up into the barrel, and what I'm going to do now is put a little bits of clay near the valve pockets and on the sides of the squish band. The squish band area is here. It's not really a full squish band, but it is at least a half of one. And then I'll go ahead and I'll put the head on and bolt it down after I run the piston through its top dead center. And we'll see how much room the clay squishes down and how much room there actually is available. for this piston. Okay, some people use plasticine. I've got clay around, so I use clay. And this will give you an idea the clearance area that I'm looking for. And now what I'll do is I'll rotate the piston by turning the crank and bringing the piston down below the surface, and then I'll install the head without a gasket and cinch it down a little bit with all 4 nuts, and then rotate the crank through its highest point in order to see how much room, how much clearance we have between the piston and the head. So now with the piston down below, I'll just lower the head, put some nuts on. I won't make you wait for that. And then just secure the nuts. This is the last one. And then I'm just going to quite simply rotate the piston through top dead center, and I can feel a little bit of stress as the clay compacts. Back and forth over the top area and back down. And then I'll take everything apart and have a look. Okay, now with the head back off, I have the opportunity to look and see what gives here. And basically what we've got is this area right in here, this semi-squish area, is practically hitting the head. The same over here. Now we haven't involved valve actuation as yet, opening and closing of valves, but with the valves solidly closed, these areas haven't really even been touched, but the squish areas definitely have, even to the point where when I have a look at the head itself, there is remnants of the clay on the squish area of the head, or the semi-squish area. So this piston, it's another way of saying that this barrel is going to have to be spaced from the underside or from the gasket side. So what I'll do now is I'll do it again, only this time with a 50 thousandths gasket between the head and the barrel, and we'll see what else we get. I got to clean this up first, and then I'll start all over with a 50 thousandths gasket up here between the head and the barrel. Okay, even after I cleaned out all of the gasket material in the bore hole where the barrel sits down, the barrel is still fitting a little bit tight, possibly because I elected to use no gasket, and therefore the hole is 10 thousandths smaller in one dimension. So what I did was I took this is steel blue, machinist blue, Prussian blue, whatever you want to call it, but this material I laid down over the area. I used a brush to put this on, and then I put the barrel back in the hole, and wherever it fit too tight, it would take the blue off. So I'm just going to do a little bit of light sanding on the bottom of the barrel there to make sure that it drops in and fits nicely. So a very light dressing with pretty much 400 grit sandpaper on a belt. Should do the trick. Make that a little more stable. Okay. And like so. I'll finish up here and then put it back into the case. And so, as you can see, it didn't take much, just a little bit, gently, to be able to have this thing drop down. Okay, so I will now pull it apart again, reclay the piston, put a 50 thousandths gasket around the head, and we'll try it again. Okay, this is a 50 thousandths copper gasket. I like these because you can anneal them, and the way one anneals them is heating them red hot and dropping them in cold water, and they get really soft, just the opposite of steel. How do I know that it's 50 thousandths thick? Because I got it in my trusty dial calipers, and honestly, if you really do intend to mess with these engines, or any engines for that matter, a set of dial calipers is truly essential. Okay, I've just taken the head off for the second rotation through with the clay, and now I'm going to take, as you can see, the gasket is in place, and now we'll get a look at the piston. Now you'll see that it's all shiny this time, and the reason for that was that I thought it would be better not to have all this clay stick all over the head, and as luck would have it, it didn't stick on the head, it just sort of made a stain, so I'll wipe the stain off of that. But I'll remove the piston and let you have a look at that. Okay, you can see the clay squished down, but then when I removed the head, it lifted itself out of position. But I think we can be pretty confident that the distance between the clay and the head itself is 50 thousandths of an inch. And when we run these motors up to 9,000 RPM, Jack Dannenberg and I have varying philosophies about this. He feels that 40 to 45 thousandths is enough, and I err on the safe side, and I like to go right around 65 thousandths, particularly when we're up around the 9,000, 10,000 RPM level, because at that level the rod has a tendency to stretch a bit as it comes over the top. And by the way, this copper gasket, as I have mentioned, can be obtained from Copper Gaskets Unlimited. You can look it up on the net, not a problem there. And you can order the exact thickness that you require, and use that gasket for nearly forever. Okay, it's 19th of May in the morning, and I am going to now take the stock springs out of this head and put some really light ones in there so that we can degree the cams on this thing. I have made my own valve compressor tool. It is a little awkward, but it works just fine, and you more or less see what it's about. Okay, I have installed light springs in the head. I've removed the heavy springs so that I won't have to overcome spring pressure. And I've also I've just actually made this from a protractor, and added some things from a Triumph wheel that I copied, and then I put a little Parilla Greyhound on it, not a big deal. But this will give you an idea as to how easy, with the light springs in it is to rotate, and yet the valves are acting the way that the valves should be acting. In fact, if you can see here, down and up, down and up. And there we're in the neighborhood of top dead center. Now the next thing is to determine actual top dead center, and I'll show you how to do that. Okay, I have made this device, which is just a piece of brass with the threads on it of the same dimensions as a spark plug wrench. You'll also notice that it is hollow in the middle so that we don't end up bucking compression. The compression, or the air in the inside of the chamber, can get out the bottom of this thing. Okay, so I have now just made a pointer. That's this critter here. And I've bent up a piece of wire and attached it to the cases. Now it's infinitely adjustable, and that's the way we want it. Okay, I took my spark plug insert and I screwed it in an arbitrary amount, but enough so that when I rotate the piston with the crankshaft gently, it will come up and it will hit this brass thing gently, and I'll read off the number of degrees before top dead center that it reads. As it happened, I got pretty lucky, and as a result of that, I'll show you how this looks. Okay, let me cinch this down. Okay, you can hear it stop at 20 degrees, but then I rotate all the way around the other way, and it turned out this time that I got lucky and it ended up at 20 degrees in the other direction. So I know in this case that when I go all the way to 0, I have got top dead center. And if you end up with 30 degrees and 10 degrees, you start making adjustments with the pointer. You got to remember, the pointer is bendable, so you can put it wherever you want. But as it happens, it almost never happens like this, but it's good for video anyway, at least for me. It stopped at 20, and I went all the way around, and it stopped at 20 again. Which means that when I unscrew, which I'm doing now, you can't see it, the insert, and it's almost out. Now when I go all the way to top dead center, which is right there, I know it's spot on. Okay, if I did mention this, I'm going to do it again, so please excuse me. We're not going to go into how to degree a cam in this video. This thing is taken long enough as it is. But what we want to do is we want to get you into the ballpark of where and at what point, at how many number of degrees before top dead center, after top dead center, before bottom dead center, and after bottom dead center, these valves are supposed to approximately open and close. And when you get them in that ballpark, for the time being anyway, Bob's your uncle. You're in pretty good shape. If you want to get lots more speed out of it, or more speed out of it, you need to look some books up and learn how to degree these cams to where they are spot on. Okay, this is really an essential tool, or something close to it. This is a dial indicator, and it has got this particular base to it, which is infinitely adjustable, as I'll show you. Turn the handle here a little bit and the snake gets snaky. You turn it back and it stays there, which is pretty nice. This works pretty well for many applications. It doesn't work exactly terrifically well for all applications, but it does do pretty well for this one. Now I'll show you how it is anchored. This is the magnet on the bottom, and you can turn it, actually it's this one here, you can turn it on or off. And if it's off, I can set it, I'll make sure you can see that, set it on a piece of steel and no problem. But if I turn it on, that piece of steel comes with it. Turn it off, it lets go of the steel. Turn it on. Yes sir, it's got the steel, and that way this allows itself to be located between that and locking the snake. You can set the dial indicator to wherever you need. Okay, now this is the dial of the dial indicator, and as you'll see as I move up and down, the needle will move. Now when it comes to a particular resting point, you can then zero it out. Right now it's at a particular resting point, and this is how I will zero this out. That is 0. So if I were to set this device on a metal plate or a metal table, and then also set a Parilla engine on a metal table, and put the tip of this on, say, the end of the crankshaft, and zeroed it out, move it back and forth, the crankshaft that is, I can tell how many degrees of side play, or how many thousandths of an inch of side play, right, as it happens. That right there is 10 thousandths of an inch, and that's about how much side play you would want on a crankshaft. The same with the transmission gears, though on a Parilla it doesn't seem to be all that important to worry about the side play, or the end play it is called, on transmission shafts. Okay, now my pal Jack Dannenberg, being the mechanical engineer that he is or was, went even further and made a device that was specific for the degreeing of valves, and even the setting of valves for that matter. So I'm going to kind of show you what this looks like by rotating this. What I'll do is, I'm at top dead center now, and both valves are open, and we are at 0 approximately. So now as I rotate this around, I will be able to see when this dial begins to move. I'm waiting and waiting and waiting, and pretty soon, there it goes. Alright, now that's an approximate reading, but you can see that I'll do it again with the dial up real close. Okay, we're starting again at top dead center. I'm going to begin to rotate the crank forward as the engine turns its proper way. I've already gone 180 degrees. Now I'm coming up on 360 degrees, and the dial just begun to move. Back it up and see when it just begins to move. And as it happens, it begins to move at just about 50 degrees before top dead center. That's as far as a standard ordinary garden variety Parilla, that's just fine. So now we're going to find out, this is the intake valve obviously, we're going to watch this needle go climb all the way, and then when it comes back down to a stop, we're going to get a reading there too. And that reading is right there, and that is 80 degrees. And if you any of you guys got the little blue speed book, you will see in the little blue speed book that 50 degrees open, 80 degrees closed for the intake valve is pretty darn good. You don't want to mess with that. And I could do the same thing with the exhaust, and you look in the little blue speed book and you'll find that instead of it being 50-80, it'll be 80-50. And if it is those two numbers, Bob's your uncle, you're fine. And if it's not, you want to make some sort of adjustments, either to the outright cam timing, or the smaller adjustments can be made with valve lash. As it happens on our race motors, Jack and I run between 2 and 3 thousandths valve lash, or that is to say when the when the cam is pointing down and not anywhere near the lifters, so that the valves are totally closed, as in top dead center on the compression stroke, we run about 2 to 3 thousandths of an inch of clickety-clack, or clearance, on the rockers. Sorry, I'm doing a bunch of things at one time here. And this will give you a rough idea of how things are going with your engine. Once you've got it to where it's, you have to fiddle sometimes, but once you've got it to where it's close to those kinds of numbers, then really you're going to be fine. If you want to dig deeper into how to make Parillas be stronger and stronger, you'll have to do some more reading and some more research, and there's always hobbyists around that are happy to help, I do believe. Okay, and just for the fun of it, to make this a little bit more visual, I took some paint from a paint stick and painted the end of the pointer red, so that you could see that we're pretty close, and perhaps now, at least parallax for the camera, at top dead center. We'll go around once, twice, and there we are. Both of the valves are timed pretty well, so what I'm going to do now is I'm going to go ahead and reassemble the rest of this engine and call this video done. We're already at, oh my, 3 hours and almost 20 minutes, and I think that's probably pretty close to enough. I'll show a little bit of visuals as to the bike coming together, but effectively from this point forward it's only a simple reassembly, and I've already shown how to do that. So it's the video is effectively over at this point. I'll still show a little more, but this is the meat and potatoes of this video. It's not a precision one, but it is one that was made in the hopes that we could familiarize the new guys and those that are a little bit timid about grabbing a wrench and getting into one of these things. And I hope indeed that has helped. Okay, I'm going to depart a little bit from the world of stock and show you an experiment I'm going to be trying here. This is it. These are fiber washers instead of the old tried and true aluminum ones that are to be used on the upper end oil feed. I don't know how they're going to work, but I have this feeling that they're going to do pretty well. I'll see. Okay, I'm going to show a little bit about this PVL system. I'm going to take this unit off of my test stand here and put it on the engine that we've been working on all this time. And I just wanted to show that when you rotate, all it takes is just simple rotation. And sure enough, things start to happen, and it's really nice because there really is no battery involved. The only battery involved in this one is to power the timing light, which we don't use at any other time other than when we're timing it. I'm going to take and show a close-up now of the sparks. They're really intense and they're pretty short, but that's one of the ideas of this kind of thing. Let's see if we can see this without freaking the camera out. No, I guess not. Okay, well, what I was trying to show is how the magnet in the center, which is the rotor, and the pickups, or pickup in this case on the side, sends a signal up to this unit here. And this unit is a trigger. This not only allows the coil, which is over here, and you notice there are two leads coming out of this coil to power both spark plugs, because all my engines are twin plugged. But this unit tells the twin coils when to fire, and the twin coils send their pulse down to two spark plugs. You can't see them both here, but you saw them in the other one before the camera freaked out. And they have to spin a little bit before these will fire, but usually once the motor's warmed up, this thing just snaps right off. Okay, now what I'm going to do is I'm going to remove that from this test stand, and I'm going to go ahead and install it on the engine that we've been building. Okay, I probably should mention that before I closed the head, I took the copper gasket that you saw earlier and I sprayed it on both sides with this material here. I didn't do it just once, I did it 2, maybe 3 times, so that it was fairly thick. Let it dry a little bit first and then sprayed on another layer and another level. Then the other thing that needs to be mentioned is that the rubber seals between the head and the timing case have got to be put on. I usually line them with a little bit of oil on the inside so that they'll slip on a little better. And the head has to be lowered with them in place. So the only thing left here is going to be to torque the head down, put the valves on it, and all of the rest of the accoutrements, and hopefully we'll be done with this, Chris. Okay, and when putting these rocker spindles in for the last time, I do a couple of things. One, I'll soak a little bit of lacquer thinner in, or soak a Q-tip in lacquer thinner and ring it so that a little bit of Honda Bond will stick, and I mean quite a little. And I put just a little on this device and just ringed it with it. Next I'm going to go ahead and put some Loctite on the end of the threads. Where the heck is that thing? Yeah, it's over here. And then I'll go ahead and put it in. Okay, I've got the valve covers on and the engine oilers on. I haven't cinched down the timing cover yet, but that'll be coming. And next thing will be to put in the tachometer drive. Then I'm going to go ahead and change the engine stand to the one that I've been using on the PVL test stand. And I'll get it up high in the air so that I can turn it around and give it a good inspection. Okay, one of the last minute things is going to be to put the trans detent in place. Well, okay, 25 foot-pounds of torque on the head, and looks to me like we're pretty well done. I will show a crank here in a little bit. This is one of the polished cranks that I did back a ways, and I'll show you what can be done with that, and then I guess we'll just wrap this up. This is the quality of work we try to do on the racing motors. I don't know if you can see this all that well, but everything has been polished before it was assembled, and that gives it a little bit of better structural integrity. The only other thing that there would be to say about this kind of thing is planning to be going into the killer motor for real, not the parade motor, but the real deal. And once again, this is we think it's 1.5 thousandths clearance, although I'm pretty sure that it's more than that. And my suggestion would be for anybody who wants to put a crank together, take it to a pro, and if you feel as though you've done enough in the way of wrenching on any motors, then give it a try. And push comes to shove, you can call me, call Jack, and we'll give you some pointers as to how to get it done. Okay, that should do it. We're all done.